Hey guys, Dave Vernier here. Now we're talking about the third design pattern, which is parallelization. All right, was able to say it for the first time. Okay, so the parallelization is not necessarily specific to AI agents because, in programming and development, especially in web, you do have some async, await calls. So it's not very specific to the AI agents, like I said, but it's still very relevant. The idea here is to run non-dependent agent at the same time, either concurrently or in parallel. This is like network calls, database calls, tool calls, or even prompts to other LLMs. You can either batch the same task to multiple agents or a different non-dependent task. That's the big thing here, the non-dependent. Like we saw with the prompt chaining, the first design pattern, we didn't need to inject the output of a call into the next one to be able to chain the prompts by definition. Now, since we are doing calls in parallel, we have to determine which call, which action can be done independently of the other ones because we don't want to depend on the result of any other things that we want to parallelize. Of course, there still can be some chaining inside a parallelized flow, but I'm getting ahead of myself. So here, the pros and cons of parallelization. The pros is that there is less latency since you can execute multiple things at the same time. You don't have to wait for the sum of the execution of them all. You're just going to wait for the longest call to be completed before being able to continue your flow. There's still the specialization pros here. You don't have to cram everything into a single LLM call. Let's say we want to use LLMs here. But you can have some very specialized prompts that do one thing but does it well. And then traceability here, kind of like the routing or the prompt chaining, you are able to see what went well, which prompt did give some good results or not. So you can optimize and find on a fine-grained level because you splitted the different calls into separate calls. The cons. When scaling, it can get a lot complex because a lot of things are running at the same time, and the observability and the debugging can become a pain if it's not well architectured. Then you can still have a context explosion. Even if you're doing calls in parallel, sometimes you want to have an extra call at the end to synthesize or summarize some things, but you did fetch a lot of things from the first parallelized calls, but you are injecting them into a single call to another LLM. Watch out for the context window here that you could explode. Here again, this is based on the Agentic Design Patterns book by Antonio Gulli. All right, so here, if we look at the N8N flow, again, you don't have to use N8N, of course. There's a lot of stuff in Python with LangChain and LangGraph that can manage that pretty well. But I like N8N especially for explaining videos like that because there is a visual aspect to it. Here you'll see that it kind of looks like the routing, but the main difference here is that all these flows or subflows here in this case are going to be called at the same time. It's not a single route that's going to be taken. All of them are going to be called. So here we start with a chat. And just for context, this is a comment or a feedback evaluation system. So let's say we enter a comment. It's going to analyze the sentiment of the comment, validate some criterias, generate a response, and extract some key points from this comment. So here, none of them depends on any other ones to be able to be executed. At the end, we wait for all of them to be completed, and then we synthesize the different calls. So here, one of the limitation of N8N is that it doesn't support parallel executions natively. So I did have to use a little trick here. So here, instead of calling directly an LLM or a tool, I'm calling a sub workflow, which is the same workflow here, but with a different trigger. The trigger is when it's executed by another workflow, which is itself here. I do the call, I pass parameters here. Since it's all LLM calls for the sake of the example, it's going to be simpler here. I send the prompt, the system prompt, the user prompt, and which webhook to call once everything is done, the names of all the prompts, and the actual execution of the current execution ID. So here in the sub workflow, when it is being called, it's calling the LLM. Once it's done, it inserts in the database. Here we're using the new data table node from N8N. It inserts a row with the execution ID it received, the result it generated, and the name or the ID or of the actual prompt that that is being called here. Then I fetch all rows of the same execution ID, and I look at if every rows or if I have a row per execution received. That's why we need to receive the all names here. So all names is an array of all prompts that are going to be called in parallel. So here, when we see all names of every prompt into a single execution or associated to the same execution ID, we are calling the webhook that the main flow is waiting for. All right, so let's say I enter, or at least I'm going to get some other comments, actual comments from Amazon, not that one. Let's see here. All right, so this is someone that's really not happy about their headphones. Let's go here. We enter the comment into the chat and we execute it. So here you saw that everything has been started and we were waiting to be called back once everything is done. One key point on N8N here, if you don't want to wait, because by default it's going to wait for the completion of it, you do have to add one of the options and disable the wait for sub workflow. So that way it's going to start the workflow, not wait for its completion, and then continue its way into the flow. That's why we have the merge and the wait here, because once it has been completed, it's calling back the webhook, an internal webhook, to continue the execution. So here we did receive the results. So we do have a synthesis of every single sub workflow, sub calls. So the user, clear frustration, disappointment, yada, yada, yada. And we do have the steps here. So the sentiment is predominantly negative. Some criterias, I can show you the criterias, which is, let's see, criterias here. So we want to validate if the comment is objective, constructive, helpful, and relevant. So it provides a personal experience. Areas of concern could be helpful. The tone is subjective and expresses frustration, which goes against one of the criteria. Then the key points. We do have a summary of bullet points of what the user said, and the response that could be generated to respond to the user. Thank you for sharing your detailed experience. We truly appreciate, etc., etc. Now, if we go look at the executions, here we can see that my initial call, so the chat that has been sent in the flow, has been started at 21:48:09. And here we can see that at the same second, all of the sub workflow have been called. So they are running in parallel with different durations. So at 9:48 and 3 seconds, the first workflow has been started and it lasted for 1.49 seconds. And same here for every single workflow. When we look at them, here at the end, we see that the if has not passed, so it's false, because not all sub workflows have been called. And if I look at the last one, probably, yeah. Since it's the latest one, that's the one that's finished at the end that we'll call the webhook, because every other ones did add an entry in the database before. And then they called the webhook, which brought us back here. And we were able to then synthesize by injecting the results of all of the previous calls. So that's it. This is the parallelization for AI Agentic framework.